I'm going to start with the first question, and that's about your full name and what you do in this circle of bioengineering and what's your field of research.
Hello, thank you for this opportunity and for this interview. So I'm Nicolas Roux. I work here at the Institute of Social Ecology and started in the project of circular bioengineering. In this project, I'm doing something different than the others are doing. There's many hardcore natural scientists in this project which are developing super cool biomass-based products which could be used for the future of our materials and many chemicals. The thing is, these products, they need inputs, for example biomass, and my role in this project is to understand, or it's more like a thought experiment. What if these products become big, like we make them at large scale for an entire country, for the entire world? Then we have to think, where do we get those inputs from? Do we have enough of it? Do we have enough biomass in area also to produce that biomass? So agricultural fields and forests to produce those super cool products. But on the other hand, if we make so much of it, this might have impacts on the ecosystems and on greenhouse gas emissions and so on. So, as we don't know, it's not something we can see. It's not in the real world. It's something that we have to think about what would happen. Then we need modeling.
Mm-hmm. We're not in a standard lab, although it's a lab talk. But can you explain about your research environment and how you collaborate with your team?
Sure. So, as you say, I have no fancy machinery and glasses except my glass of water which I drink from. The only thing I have here is a desk and a laptop and two screens, because it's a little bit more modeling and theoretical what we do here. But we have a great team and we're really collaborating together. For example, the model we will use here for this project, it's called biomass. The name stands for Biomass Balance Model. The goal is to see biophysically, without making assumptions about economic behavior and things like that. Just biophysically, what happens if we need more biomass to make materials, plastics or buildings and so on. Well, then either we need more space or we need less biomass for food, for example. So that's where it becomes interesting. If, for example, we eat less meat, we then have more space, more agricultural space that can be used for non-food purposes. And this is why it's a balance. It's always the balance: how much can we produce, how much do we consume, and if we change something, if we want to consume more for making materials, then we need to consume less for food, for example. And this model was started to be developed already 15 years ago or so, and a very simple framework by my professor Karl-Heinz Erb and his colleagues from that time. And over the years, many colleagues have improved on the model, and here will be two at the Institute, two postdocs, Benjamin Fleischmann and me, and our chef, Karl-Heinz Erb, using that model to make a further step in this modeling, namely including forests and forestry and wood use. In this
you mentioned that you're working with some models, but can these models actually help us avoid some unintended consequences when we're talking about biomass and biomass production?
Yes, I think they are quite important because there is this idea, it's very deep in us, that biomass in wood or like products that are made out of plants, and that these are super sustainable and they have great benefits. I mean, obviously, it's using less oil and fossil fuels and all of this and this. That's definitely a wonderful thing, but biomass is a very limited resource. We already have a very big biodiversity crisis right now, and the biggest driver of the biodiversity crisis is the way we use our land. We use a lot of space, and we use it very intensively. We have intensive agriculture, intensive forestry, and if we want to have more biomass, then we will increase these pressures, and this might have important impacts on biodiversity, but also on climate change, because if we use the forest more intensively, we can store less carbon in the forest. If we need more space, we prevent also the opportunity to restore nature. So that's a big trade-off here when we want to use more biomass. We have to think of this: what are the consequences then for the ecosystems? So especially when I think I think many scientists are in the lab making those wonderful products but not really thinking of what would it mean if really industry takes it up and starts saying, we're going to make this at a large scale. And there the models can help to make us those experiments.
So when you're not in the lab, how would you spend your time?
On the one hand, I'm also quite dedicated to scientific activism in a sense. So I'm in the group of Scientists for Future, in one subgroup of it, which are making actions in the public areas. And sometimes it's protests, but sometimes just making a speech on the street or in front of a ministry. And it's a lot of fun also. We have a great team. But also I like to play music in a band, and I practice judo sometimes once in a while. But also
collaborating with a Cluster of Excellence in Kilometer Engineering.
Yes, I'm really excited about it. So I'm still a bit new, so I have not been collaborating a lot so far. But we had this one meeting a couple of months ago, a whole day, and I felt again like back in my bachelor studies when I was also having some chemistry courses, and I was really impressed how fast we could still understand each other. I noticed that all the people in the room were used to this sort of discussion, and that they rapidly could think out of the very complex chemical formulas they have to understand that we wanted to have those inputs for modeling. I was really.
Are you a tea or coffee person, and what fuels you in your working day?
I'm very sensitive to caffeine, which is the same as tea, actually. I can't sleep at night if I drink any of these, except in some particular situations when either I did not sleep well or I feel like I need some boost today, and then I drink like one sip, and then I'm like boosted for the next 5 days.